Okay, your test kind of has three main ideas. So the first main idea is word problems. I'm just going to give you any kind of word problem you're going to have to figure out. Did I ask how many arrangements of something or combinations of something? Second chunk of your test is factorial expressions and equations. And then the third part is the binomial expansion questions. Okay, I have 5 pairs of shoes, 6 pants, 8 shirts. How many different outfits are possible if I have to choose one of each? So, I'm going to have 5 pairs of shoes and I'm going to have to choose one shoe. And so what do I write if I said the word and? What am I writing in math? Multiply, and I have to choose a pair of pants to wear. And I will have to choose a shirt. Okay? Does anybody know what 5 choose 1 is without their calculator?
5.
Just 5. Okay, so there's 240 outfits. So you might be wearing your sandals with your jeans and your tank top, or you know what I mean? So you might have that kind of thing going on. Okay, how many ways can you arrange these letters? So you start with how many letters there are. So there's 11 letters that I can move around. When you have 11 objects and you move them around, that's just a factorial. But think about the word dad. If I can move the first D and the third D around, does that make any difference to you? No. So it's the same thing. So it's like I'm canceling things that are the same. So I'm going to cancel. So that means divide. And what do we have as anything repeating? We have a bunch of E's. We have 5 E's, so 5 factorial would get canceled. Is that it?
2 P's.
2 P's. So those are the cancels. When you're typing this in, you need to be careful. You would need brackets. If you're just going to type it all into one step, you better put brackets on that part. Okay, number 3, we're choosing a committee of 4 people and we have a group of 13 to pick from. So how many committees can be made? So the N and the R, we have a 13 and we have a 4. My question is, which letter would you use?
C.
C, because you're picking groupings. You're not worried about the arrangements involved with those people. So be careful when you're doing these problems. Think, am I worried about the arrangements, the ordering, or not? Okay, explain the difference between a permutation and a combination. So this is your arrangements, and the order would be important. The order matters. And a combination is the groupings of objects. So the order doesn't matter to you. In a different group, it doesn't matter about your order of things. Let's do. Okay, there's 18 desks for 12 students. How many ways can the students be sitting? Like how many different seating plans could be designed? So there's an 18 and there's a 12. So you're deciding which letter to use. Did you pick a P? Because you're worried about the order of things. You can move around in those seats, right? This is probably going to be pretty big, isn't it? Does it even work? Oh, it's so big. 8, 8, 9. I won't put a number that high. That's how big of a number it is. I don't even know what.
Is it all right if we just wrote it down in scientific notation?
As long as you understand that. It's not that there's 8.9 arrangements. As long as you understand that that's a massive number of arrangements. Okay. A factorial simplification. So when we have the factorials, my strategy is to always expand the one that's bigger. So I'm going to tackle the 81 part. So 81, then go down to 80, then go down to 79, and beyond and beyond and beyond, right? Don't forget your exclamation point, because that is a communicating error. Okay, do you understand 79 and everything below that would cancel with the 79 and everything below that? And then the rest you can do in your calculator. FYI, if you tried this in your calculator, it won't even work. So you got to know the strategy. 'Cause it's too big of a number. Okay, the instructions on this one said show how you would do this without a calculator. So you're going to have to show me what you're doing. Okay, so we're going to expand. And do you understand thinking ahead? I'm going to start the 12 and get down to the 8. Okay? We also have a 4 factorial. I think we're just going to have to do that separate. Okay? Okay, so 12, go down. So I thought about the 12 and I thought about the 8, so I kind of set that up. And I think we're just going to have to do the 4 factorial as well, just as a kind of a separate thing. Okay, so I picked the 8 factorial to go to because that will cancel the most. Okay, now let's do some canceling of stuff because I can't use my calculator. So are you okay to understand that would cancel, right? Because the 4 times the 3, I'm going to say is 12 cancels a 12. And then we can cancel what? Should we do the 10 and the 2? So I'm going to go cancel to a 5, cancel. Okay, and that's kind of the work that you're showing me, how to simplify things without having your calculator involved. Do you know how to do that fast without a calculator? Do you know how to multiply by 11? When you multiply 11, you split those numbers and add in the middle. You get it? So 4 and the 5 split apart, and then they add to the 9 in the middle. So what's 11 times 71 without your calculator?
781.
781. Look how smart you are. Tricky though. What's 11 times, let's go 67? So you split the 6 and the 7, and it adds to what?
700 and not 13.
So it adds to 13, but you can't write 13 in the middle. So you would go carry the 1. Look how smart you are today. You can show somebody that fast. Because it said without a calculator. Okay, you want to find the 4th term. Then I'm basically saying you're going to be doing the what, choose the what. The what, choose the what. So if I want to find the 4th term, then the n is what, choosing the what. Did you pick 11? Because that's just the exponent. And when you do the choose, you're going to have to choose a 3, right? Because it's 0, 1, 2, 3. That's the 4th term is on the 3rd count. How many terms are there when you expand this whole thing out? So if the exponent is 11, when I'm done, there would actually be how many terms? There would be 12. Because we started counting at 0. You're going to be choosing a 0, choosing a 1, choosing a 2, choosing a 3, right? Okay, so that is 12 terms. And, right, that's when we were on the 4th term. Okay, so count from 0. Show off all your math. Count from 0. Okay, expand the larger one. So I'm going to expand the n plus 2. Do I already know where I'm going to get down to? You're going to get all the way to the next factorial. So you got to get to an n minus 1 factorial. Okay, so there's your expansion. Plus 2, plus 1, just an n, and then a minus 1. Okay, are you paying attention to what's got exclamation points and what doesn't? That's important. So this and beyond would cancel this and beyond. This is just a single thing canceling a single thing. And so I have n plus 2 left and an n left. But this says to simplify. So if you are simplifying something, would you leave it as 4 times 5 or would you go further? You would times it. So can you times that together? So on your test, when you're seeing that simplify, okay, do you understand that simplifying and like something looking like factoring is the opposite thing of each other? So if it looks like it's factored, simplifying means to go expand. What happens if I had done this and the cancels were on the top and these things were on the bottom? What do I make sure I put as an answer? 1 over something, right? In the expansion of this, which row of Pascal's triangle would correspond to this expansion? You know what? Can I just change this question? Can we just expand this? We're gonna, because you have one on your test. I want you to expand. Okay, so let's go to the triangle. Where do you want to have room here? I'm just going to go to the side here. Can you expand into a row where you're seeing 7 terms? Okay, so we're going to have 7 terms in our expansion, and these are all the coefficients of them. And the reason is that there's no coefficients that change it, right? Ones and ones, they won't change these numbers. Okay. Now let's write the variable chunk behind there. So this would have an x to the 6th and no y's. This would be x to the 5 and a y. I went down and I went up. This would have an x4, a y squared, x cubed, y cubed, x squared, y4. Whoops, what am I doing here? Okay, so those are the terms. I put the coefficients from the triangle and I went in order down exponents and up exponents. All of it, obviously, when I look at all the exponents in each term, it's always 2 plus 4. It's 6. The exponent's 6. Because this is a positive and positive term, everything's positive, then there are plus signs in between. What if this y was a subtract y? What would change? Plus, minus, plus, minus, plus, minus, right? Be careful on that. Okay, write the next row. So can you tell me the next row in the triangle after that one? What am I doing here? 56. Thanks. Are you kind of noticing the symmetry too, right? It always flip-flops. Oh, we just ended up doing this one. Can I change this question? Let's go. Let's put a minus sign in it then. Just because we did almost the exact same one. Okay, expand that whole thing for me then. So start yourself with a triangle. If you prefer, instead of the triangle, you can always just go 5, choose 0, 5, choose 1 in your calculator. Whatever seems faster to you. You can get all those numbers separately, or you can just do the triangle. Whatever way is faster for you. that laughing or coughing? I'm not even sure.
I think someone's about
Both?
to throw up.
The both. That's what I thought. So that's gonna happen over here.
I think that's what I was scared of. That's why I left.
I know. It's like you should go. Okay. So do you see how I could have just done the triangle, or do you see how those numbers? Doesn't matter. They got me to the same numbers, right? Okay. So I'll spread these out as my coefficients. Okay. If you want, you can start x5 and then go down. Down. And then starting your y's, I don't know, maybe you like to start on the right hand side and then go down. I don't know, whatever your method is here. Go upwise, x's go down. Okay, but this time, because I changed the question, what would you be doing here? This term is positive, and then we'll subtract, then we'll add, subtract, add, subtract. Okay, so you will have some kind of expansion on your test. I will ask you to do that. Okay, find the fourth term. Okay, so tell me, choose what is in the front? Did you pick 7, choose 3? Fourth term, so we'll go down one. Place the first unit in a bracket, place the second unit in a bracket. Okay, I always take the 3 exponent and I put it on the, which one of them do I put it on? The last. If you aren't understanding why I'm putting it on the last, I'll kind of show you why. Because this was a 5, choose 0, 5, choose 1, 5, choose 2. Do you notice how this is a Are you noticing the connection here? Whatever you're choosing, right? It's always on the last. Okay, so what you're choosing is on the last, and then this exponent is a subtracted, because you always have to have your exponents make up to the 7. So 35. Okay, a simple mistake to make is forgetting to do 2 to the 4th. I get that a lot. I get people who do x to the 4th, but just write 2 and forget. The 2 is to the 4th. So does that make 16, I think? And then the same thing, don't forget the 3 coefficient changes. So that should be 27. Okay, which term contains the x to the 13th? So when I'm asked this question, I am going to disregard all numbers, coefficients. I'm only going to consider the variables. So I want to end up with an x to the 13. And where are the x's coming from? Well, in the first unit of x's and the second unit of x's. So again, I take each unit in brackets, but this time I'm just no coefficients are involved. Which term, so now I don't know the choose number, I don't know that number, so I don't know what number I'm choosing. And then I know that this one is always after I've subtracted. Okay. If you're okay, I'm going to drop the x's and I'm just going to say all the exponents need to equal each other as an equation. So 13 equals, you'll have to times that, 52 minus 4k What? I'm like way off my game today, hey? What? No, that was right.
Yeah, but
Where am I looking?
when you have k, like x4, isn't it a 12?
Yep, I see ya. Sorry. Yep, I was looking back at my x. 12 minus k. Yep, there. Monday brain. 12, because I was looking at the wrong spot. I needed to look up there. I probably would have noticed my mistake when my answer came out as a decimal. Okay, let's move the 48 over. Negative 35. Remember, this answer needs to come out as a whole number or else it just something went wrong. You did something wrong. So I would have noticed if I had, my mistake was 13, putting 13 in there, I would have noticed somewhere at the end here my answer was wrong. K equals 5, but that's not the term. So what are we going to answer? The sixth term. Because the K is that we would have done the something choose 5. Okay, find the first term. So what choose what would you write if you were doing the first term?
12 choose 1.
12 choose 0. You always got to go one lower. By the way, on your Pascal's triangle, your first term would always just use a 1, right? Every single time you started the Pascal triangle, it was always a 1 on the first term. 1. Okay. I wrote the first unit and the second unit. Do you notice how I maneuvered the second unit, right? So this will have a 0 and this will have a subtraction, so a 12. 12 subtract 0. Do you understand this value is just 1, right? Or if you, whatever, if you're just understanding, I'm just crossing those off, they're both 1s. Okay, so your final answer is, what is 3 to the 12th? That might be big. Okay, back to a word problem. We have 5 boys and girls, so that's 10 people. They're going to sit as couples. So what I'm going to do, this is kind of my strategy. You might not necessarily need this, but I'm just going to draw 10 chairs so I can kind of understand visually. So if they're going to sit as a couple, So let's just pretend these two people would have to always stay beside each other when they move around. These two people would stay beside each other. So when I'm maneuvering people around into different spots, these two people are moving together. I can't separate them. Okay, so how many units are we now going to have? There's just 5 units. Then within this unit, what's going on within the units? So these two people could also move around. So could those. So I'm going to do that to the 5th exponent. Okay, because that's each unit can do that. Okay, see if you can type that in properly. Okay, boys and girls want to alternate. So on this question, again, I just say, here's my 10 chairs, and I'm going to think about who can sit where. So if I went to put somebody on the first chair, how many options, how many choices do I have? I can put anybody on the first chair. Doesn't matter. Then I pretend I put, let's say, a boy on that chair. So now going to the second chair, how many options? Now I would have 5 girls to pick from. Now if I'm thinking I'd be going back to a boy, I would only have 4 boys left. Back to a girl. Okay? If you want to do this faster, the boys, the girls, but I could have started the line with a girl or I could have started the line with a boy. So then that's 2 options for how I could have started. Okay? Okay, what if people want to sit beside each other or not sit beside each other? Okay, so now we have 6 boys, 6 girls. So 12 people is what I have. But Will and Kate are going to sit beside each other. So now I'm treating them like a unit. So how many units can I move around now? Did you pick 11? Because they're treated as 1. Then what could happen within Will and Kate's unit? It could go Will Kate or it could go Kate Will. They could flip-flop. Okay, question B, what's the strategy on this one when we say that Will and Kate don't want to sit beside each other now? Do you remember this? All possible minus the opposite event. Okay? If you forget that strategy, I don't even know how you would figure it out. It would be very complicated. Okay, so what's if you had no restrictions, just what's the total possible arrangements that could just happen? Boys, girls, doesn't matter. What would just be the all possible? 12 factorial. There's 12 people moving around. So do you understand that in question A, that was the opposite event, right? If they don't want to sit just beside each other, the opposite is if they are sitting beside each other. Okay, so you'll have to recognize that one. Okay, number 6, the committee picking. So we need a committee to have 4 girls on it, 2 boys. We have 12 girls to pick from, 4 boys to pick from. So how many committees are possible? So I need 12 girls to choose 4 from. And so I'm going to do a multiply. I'm also 9 choose 2. What if on the test I asked you, forget boys and girls, doesn't matter, how many committees would just be possible? All committees. What would you do? If it didn't matter, you were just trying to make that committee without worrying about if it's a boy or a girl, what would you do?
21 choose 6.
21 choose 6. Yeah. Because you're just taking anybody. So there's 21 people, and you have to get 6 people on that committee. Okay, how many committees are possible if Andrew or Jesslyn need to be on the committee, but they both can't be on at the same time? So we have separate situations. We have either this possible or this possible. So when we have an or word, we're going to be doing a add. So situation would be if Andrew was on and Jess was off. Or the other would be if Jess was on and Andrew was off that. Okay, so if Andrew is on, you don't even have to write that, but that's Andrew. 1 choose 1 is Andrew. Okay, ready? We need how many more boys to put on here now? So we needed 2 boys, but Andrew's already on there. So that's already 1 boy. So we need to choose 1 more boy out of how many picks? 8. Because remember, Andrew's out of that picture now. He's not a pick. He's not one of the 9. So 8. Then we are going to have to choose 4 girls. So we're going to choose 4 girls out of how many options for picking? I only have 11 picks, right? Because I can't look at Jesslyn when I'm doing this. So I only have 11 picks. Or, so I'm going to add, so if Jess is on, that's her, 1 choose 1. You don't have to write that if you don't want to. Okay, so if she's on, I need to choose 3 more girls And instead of 12, I'll have 11 picks. And then I'm going to have to choose 2 boys yet, only from 8 options. Okay, so take those options down. So this is very situational. You'll have to do some thinking about what's going on.
Put either of them.
What?
You put either of them on a committee, is that an option?
Oh, or just needs to be on the, but not both.
They need.
Oh, okay, you
Right.
need.
Okay, that's a really good question. So, do you understand when we're talking about this situation, there's actually 4 possibilities, right? We could have a committee where they both are on. We could have a committee where Andrew's on, Jess is off, Jess is on, Andrew's off, or a committee where neither are on. But it did say that one of them had to be on, so then that only made those 2 cases. Okay, if it just had said Andrew or Jesslyn had to be on the committee, do you understand you would have to do 3 cases then? Because then you would also include the case where they're both on. Or you could do 1 minus the opposite event. You could do 1 minus the event that they are both on there. Or neither are on there. Okay? So that would be playing around with either adding all separate cases, or you could do 1 minus some opposite events. But there's 4 scenarios. Do you understand how that would break down? I see there's a type of question that you might run into that I didn't put on here, but I might ask some kinds of questions that say, at least 3 girls have to be on your committee, or something like that. Okay, when you do at least, you got to add, because you would have to do, if there's a committee of 6 and you would have to do at least 3 girls, you would have to be, well, what if there was 3 girls on there? What if there's 4 boys? What if there's 5? Or what if there was 6? Okay? Okay, solve a factorial. Okay, so this one has the NC2, so this would be me looking at my formula sheet. I guess I'll have to print you those formulas. Remind me, I think I have it memorized here, but is this the formula? Some of you, I'm not sure if you like to write that over 1, just so you have your fraction stuff, but whatever. Okay. So my strategy will be expanding the bigger factorial. So n So I did the expand the bigger factorial, and I also just expanded 2 factorial, which is just 2 times 1, which is just 2. Okay, so that and beyond cancels. At this point, I'm going to tell you what I'm doing is I'm either cross multiplying or I'm multiplying both sides by 2, the same kind of math concept. What is that, 56? Okay, so you can see I either cross multiplied, you can say that, or I multiplied both sides by 2. Okay, what are you going to do with something that looks like this? This is algebra stuff now. We're going to have to strategize algebra, so expand that. Now, this is my algebra branch. If I see n squareds and n's, if I see 2 variables, I need to, what? What's always the first thing, no matter what? Equals 0. Always equals 0. Okay, I think I recognize it to factor it as a simple. 7 times 8. Okay, now you'll lose a point if you don't do something at this very end spot. I need to just do one more little thing, or else I lose a half a point. What is it? That doesn't work. Only one answer, right? You can't have -7 items and choose 2 of them. Doesn't make sense, right? Okay, so this is my next one. So I am going to look at my 2 factorials and expand one of them. There's my 2 factorials. Which one do you want to expand? Okay, so I expanded. So n minus 3 factorial cancels. N minus 1 cancels. Okay, can you finish this off? It's actually going to be the same steps as the last time. It looks almost the exact same. Okay, on this one too, I have to be careful. This will not work for me. And it's not because it's a negative value. That's not the reason it doesn't work. It's because when I plug it in, -6 minus 3 makes -9 factorial. So that's where it doesn't work. If I had something like this, -6 would be fine. Do you see that? -6 would be able to be a solution then, because -6 plus 10 makes 4 factorial. Okay? So it's not that it's negative, it's that when it's up there in the original, it makes a negative factorial. Okay, 5 boys, 5 girls seated. Arrangements. Brennan, Will, Delicia want to sit as a group. So if I have my 10 people, and out of my 10 people, the 3 of them are sitting in a row beside each other. How many items of groups are you moving around now? So you're moving 8 groups around. And then within the group, they can move around 3 factorial. Okay, question B is a little bit different, so I'm going to draw it out. I have to put, the girls have to sit on the 2 seats at either end. So those seats have to be the girls. Have to be girls. So let's talk about those seats. Okay, how many options right here do I have? I have 5 girls that could sit there. Okay, now moving on, I'm going to put somebody right here. Now I only have 4 girls to pick from. Okay, jump over to this side. Now how many people do you have on this spot to pick from? 3 girls and then 2 girls. Times how many people do you have left that you can put anywhere? You put 4 chairs already, so I still have 6 people. And if you had thought about it separately, you would have just said 6 people in there, 5, 4, 3, 2, and 1. Okay, the last page has a couple more binomial questions on it. Okay, find the value of n, so find the exponent, that's what I'm looking for, if the 7th term is equal to that. Okay. You ready? Do I have enough to solve this even? What's that? Okay. So I would be starting like this. N choose 6, right? Because I'm trying to find the 7th term. I don't know if I have enough to solve this, to be honest. You know what? I think I'm going to have to do this in stages. How about let's figure out which term has, or let's figure out n by just taking the x stuff. Because if we take the numbers, I don't think it'll work because I'll have too many unknowns. Right? Because watch, this is what would happen. So this is what would happen if I kind of set it up. So I don't really know that number. I know that this exponent would be 6. And I know this exponent would be n minus 6. Now, do you understand if I was trying to work with the coefficient stuff? I don't know that piece, and I don't know that piece. Okay? So we're going to drop all the coefficient stuff, and we're just going to do the x stuff. Okay, so same strategy here. X to the 4n minus 24. Okay. That's why the coefficient stuff doesn't even matter. So exponents equal exponents. Okay, so 4n equals 48. N equals 12. Okay, and that's it. This isn't one of those where you have to change one higher. Okay, because I'm just saying what's the exponent. So there would have been a 12 up there. Okay, you don't change it. Okay, let's try this one. This one I think we're going to have to do coefficient stuff on. Okay, so let's try to set it up here. We're going to go 9 choose, because that's the exponent. 9 choose the 7th term, so 9 choose 6. bx5, 2x negative 2. I know all the exponents, don't I? Because this would be a 6 and this would be a 3. And then I want to end up with this.
You're still teaching?
All right, I mean, you could come in.
No, I was just gonna ask the word comments.
This is my last question. Okay, 9 choose 6. So I'm at 84 there. And b cubed, can't do that, so I'm just going to go b cubed. And then x 15. 2 to the 6th is 64, anybody? X negative 12. So we should already see our x is going to, they should match, right? Okay, is this okay? X3, that's good, right? $84 times 64. Okay, so I put the 84 and the 64 together. Can we cancel the x3s? Okay, now I'm going to divide. Does anybody know this one without their calculator? What would you cube to get negative 27? Negative 3. Okay, cubed root, we should know it's negative, right? Because the only thing you can do to get a negative is to cube a negative.